Oh, that came in the recording. No problem. Okay, so next we're going to tackle sets. And sets are very easy peasy. Trust me. You're just going to use a knowledge of dictionaries and probably be there. Can you see my screen? Everybody see my screen?
Yep.
Yes.
Okay, so this is what set is. A set is simply a dictionary with only the keys. A set is simply a dictionary without the values. That's basically what a set is, right? So if you have solving any question and you feel like, so look, a dictionary allows you to look at things in all of one time. You can simply set, is the key in it? Oh, also note, if some key in some dictionary, it's going to only check the key. So it's going to only like just compare the key portion, right? That's all it does. I said a dictionary doesn't give you a magic look into the values, right? A dictionary doesn't give you superpowers to look at the values, no, because it's the keys it deals with, right? It hashes the keys, then it goes put it into that your container or something, right? So a set, it's simply a dictionary with only the keys portion. That's what a set is. So you're solving the question, you want to track something, you want to get all these superpowers, like look, you want to get all these superpowers we talked about here, but you only care about the keys. That's when you use a set, right? So that's what a set is. A set is just like a dictionary, but it only focuses on the keys. It's just the keys collection of it, right? Okay. So on that note, again, we need to care about search, searching, insertion, reading. Reading is funny though. Reading and then deletion, right? Okay. Searching the key in a sense is the same. Oh, by the way, how do we create a set? This thing. How do we create a set? Anybody? How do you initialize? How do we create a set? I want to create a set called scene. I usually call it scene or vista. Scene. How do we create it? Anybody? Scene is equal to what? And nay. How do we do that? Today be today. Anybody? Nobody. Okay.
Scene is equal to set brackets. Yeah.
Create a set. Please, if you do this, you have created a dictionary. That confuses people. When you look at the entries, they all use braces, but in the initialization, it is a dictionary initialized this way. Dictionaries ended up bullying sets when we were writing this programming language. So yeah, this is how you create a set. Please don't forget. It's the same thing with tuples, right? If you're initializing a tuple, right? Don't worry, let's focus on sets, right? This is how you create a set. If you put an entry inside the set, it looks like this, like one, right? Can you see? It's just an entry. But look, we use the braces just like the dictionaries, but it's not a key value pair. If you want to make it like 1: something, it becomes a dictionary, right? So a set is just the key portion, right? A set is just like a single entry. Does that make sense to everyone? Now we already established that what are the types of data you can use as the keys in a dictionary? Is it mutable or immutable? Anybody? Mutable or immutable? I need to force the keywords into your head. Anybody? Immutable, right? The same thing for a set. A set also has to be immutable because we said it's just like the keys, right? So that means you can use strings. You can put strings in a set. You can put integers in a set. It's something people don't know. And they try to put lists in a set. It will not work. Set will scream at you, like Cornelius mentioned it. It will not work, right? You can also put, tuples inside, right? It's the meaning the ones we focus on. Okay. So that's not about the initialization. This is how you initialize a set. And you can put, let's see how you can put things in insertion. How do you insert? Anybody? Save me.
Set.add.
Yeah, you do a dot add. Then you put the value, right? Set dot add, right? Section, you can use scene, right? You can use in, right? It can be like if your value in sets, right? In the sets. You are there, right? Then there's also reading is funny though. Okay, so the thing about reading is this, because sets just have these guys, right? So sets are more like, have I seen you before? That's why I usually call mine seen or visited. Whenever you see sets in my code, it's almost like seen or visited. I'm like, have I seen you? Have I visited you before, right? So you don't really read from it, right? Like it's just like like it's not like a key value thing, right? Like you're not reading any value. So I'm just going to skip this, right? Deletion. Can we delete from a set? Anybody?
I think remove?
I think that's a remove. We will prove it later. Yeah. So remove then the value, right? Now, if you already have a set, look at this. If you already have a set, 1, 2, 3, and you do a s.add 2, what will happen? Anybody? What will be the output? Anybody? Somebody help me. S.add 2.
You can't add it because sets don't take duplicates.
Yeah, but it will not give you an error or anything, right? It will just go and be like, just go replace it. Right. It will still be the same thing, right? It will be the same thing. In the same way, if you have a dictionary, look, if you have a dictionary, a map, and it's like 1 is 2, and 2 is 3, all right? And you come and do map, of 1 is equal to 5, what happens? What will be the new map? Anybody?
1 maps to 5, 2 maps to 3.
Yeah, but it become 1 map, right? It's basically override. So I'm trying to tell you this. Yeah, it will override it, right? If you bring something new, it will prioritize that and to just override it. Does that make sense to everyone? Like this, they will override whatever it is you have, right? So like this one coming in, just fix it in, like it's just override it. Because it can't keep duplicates, right? But you can't keep duplicate, it will prioritize the new thing you're bringing in, just shuffle it in. Does that make sense to everyone? Okay. So
Question,
as we said,
please.
yeah, go on. Ask a question.
It's saying the set, you cannot read in a set, right?
Yeah.
Okay, just to search, insert, and delete from a set.
Yeah. The section returns like true or false, right? So it's more like are you in? Like are you in it? Right? Like are you in it? Like right.
Okay.
And that's what you search for. And it's like, have I seen you before? Are you in? So quick question. Quiz number 1. What is the time complexity of searching in a set? Anybody? What time it's constant time, right? Because you just take it, you hash the value. All right. If you want to search, you're like, is value in it, right? It hashes the value, right? Then it gives you some bucket. Go and look in that bucket. Oops, you're not in the bucket. It returns false, right? If it's in, it returns true. So it's O of 1. It just hash, look in bucket. And hashing is just a mathematical computation. Computers are so good at math after me. Okay. Then what about insertion? What about adding to a set? Constant time. Well, I already answered for you. Sorry. Constant time, right? Because insertion is the same thing. Hash, get a bucket, put inside the bucket, but you are there. Deletion. Deletion. O of 1, right? So it's all O of 1, or constant. Again, you can use sorted set, blah, blah, blah. That gives you logarithmic. You can get that later. Okay, any question on set? Roughly that set.
Yeah, question.
Yeah, go
on. So in case of the sets that are made up from the binary search trees, would the searching be would the searching be linear time or like logarithmic time?
Log n. Okay. All the sorted containers is log n. It's not linear. It's log n because that binary tree they use in the code is a balanced binary tree, balanced binary search tree. That word balanced here is what is making it log n. We look at it when we do binary search trees, which is in 3 weeks. God willing, next week we are doing linked lists. Oh, it's actually, and then God willing, next 2 weeks we're doing recursion and trees. If we have time, we will do binary search tree goal next week. But I feel like we will probably not have time. So God willing, next 2 weeks. So we are going fast. I was in a call with some people. I was like, by end of July, we would have gone through the data structures and all this cool stuff. So like you have to follow it carefully. To be honest, I was better realize we are there and you are somewhere. Okay, so that's all about sets. Please keep sets on the bottom of your heart. It's so important when you get to graphs. You're using sets everywhere because sets are good. They're so good. Sets are just like dictionaries, right? Dictionaries are like dictionary. You care about a pair of data, right? Like like key then value. But sometimes you don't care about that value portion, right? And the set becomes so handy. Comes in so super duper handy. Okay, good stuff. Okay, good to go. The line set. Any questions on sets?
Yeah, and the last question.
Yeah,
so
go for it.
yes, so just like those questions that involve like the creation of a set, like yeah, so maybe a set data structure. Would you recommend like using the list or like using the balanced BST?
Oh, you mean like design your own set, right?
Yes.
I'll use the list. This way I'll use the list. Did everybody try that question? Design hash set. It was in last week's questions. Did everybody try it?
Yeah.
Yes.
Okay. So let's take a look at that quickly, right? I saw some trail on it in the discussion, right? So the question was design hash sets, right? And those of you who have been coming to coding rooms, I usually tell you something that whenever you see design a certain data structure, right? There's a limitation. What I mean to tell you that after you design, the time complexity should be the same as that data structure you're designing. So if I tell you to design a hash set and it go and be like self.set is equal to a list, and then search, you're like, if the key in self.set, like you have violated it. Can everybody see I violated the constraints? Does everybody agree? Because you're using a list here, right? What is the time complexity of this?
Linear.
It's linear. Because actually the fact you're calling it a set does not mean it makes it constant time. No. This is just a name, right? What makes it constant time is how you implement it. The way you call it set here does not mean, well, it's a set, but it's a list you used here, right? So if you use in and this, I think that was this method. Was what? get or something, right? Get. Then like if key in self.set return maybe self.set index, maybe return true, like maybe like you're like maybe so maybe I don't know, you like self return true or something, right? Like this, you have violated it. It's no longer a hash set you're designing. Does that make sense to everyone? Whenever you're designing a data structure, the time complexity of whatever you are designing must match that of the data structure you're trying to imitate. Does that make sense to everyone?
Yes.
Yes.
Okay, so let's see how we can design this. So let's first see how the structure should be, right? How the structure should be. So let's look at our init. So the init, right? We can simply use. So look at how we first discussed it. We said it looks something like this, right? So we said the hash data structures look something like this, right? Something like this. Then they have chains like this, right? And then we can give them indices 0, 1, 2, 3, 4, 5, 6, up to infinity, right? Not infinity, but up to some value k, right? So when I want to put something in, look at what we said. We say if you want to put something in, what it is that you call some hash function, right? Then the hash function will hash that thing you want to put in. Let's call it a value, that value you want to push in, right? And then that hash value will give it to you some index, right? Then using that index should be like 0, 1, 2, 3, 4, 5, up to k, right? So if the index was like, let's say 2, that means that, hey, let's come to the 2's bucket and put a thing inside 2, right? So that in future, when I want to look for, let's say 2, I can just hash that 2 again. Let's say value is k, let's say value is, let's say 45. When I hash 45, I've got 2. So in the future, I can hash 45, like, 45, you have to go to bucket 2. I can come and find it. Like that was the whole argument, right, for hash data structures. Does everybody remember? That was a story we sang, right? That was a song we sang. Everybody remembers?
Yes.
Yeah.
Okay. So if I want to design this, I'm like, so basically, this is what you have to imitate. This is the thing you have to imitate, right? This is the thing you have to imitate. So you'll be like, okay, so I'm going to do that. I'm going to now, first of all, create this list thing I have here. So to do that, I'm going to call it, let's call it self.buckets. I call it self.buckets. It's equal to, I'm going to make it a list, but a list of how many entries. I want to give it some predefined size. So let's call that size k. So I'm going to be like self.k. So in my class, so class hash set, I'm going to have some, by the way, we have a session on object-oriented programming coming soon. I know some people are not like so familiar with like some of these things. So you can just put k here, k, and just set k to be maybe, let's set it to be 7. Now that we're going to create just 7 buckets, like 1, 2, 3. Sorry, we're going to create like just 7 buckets. I mean like 1, 2, 3, 4, 5, 6, 7. Let's make 8. It's good to choose k to be a prime number. The properties of it, but like don't worry about that. Right. So let's say k is 9, right? So 1, 2, 3, 4, 5, 7, 8, 9. So I'm like, okay, now let's create a bucket of 9 entries, right? Of 9 entries. So I'm going to do this. I'm going to take this one. I'm going to create a bucket of 9 entries. So it'll be like, every entry, let me do something here. Do this 9 times. Is this correct? Is this correct?
No.
It can lead to bugs, right? Python-wise is right, but it can lead to issues. Do you all agree it can lead to issues?
Yeah.
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 To issues, right? Because of this thing we're doing here. We just create one list and just duplicate it all along, right? And that is not the best thing, right? I hope you all know that by now. Okay, so instead, what do we do? Somebody save me. Right? You can use the follow. You can just be like self.buckets is equal to, let's just create a bucket k times, right? For underscore in range self.k. Or if you when I'm eating your fufu, you don't put this fufu in soup separately, put everything together. Just do self.bucket is equal to the empty list. Then be like, for I, nobody will arrest you. In range, self.k, self.bucket.append, right? Like you fulfill, they want it in one bowl, no stress. Self.bucket.append the empty list, right? This will also work, right? But some of the people here, they say, so yeah, it depends on however you want it, right? So this is going to initialize it. So now let's come to insert. So def insert. So now I want to insert some value, right? Let's call it val, right? So to insert, I'm like, well, we can first check if it is inside, but let's say we don't care, we just want to put it in, right? Like, easy. I'm just going to take shortcuts. This we just want to insert it in. We're like, okay, to insert it, okay, let's first check to see if it is in. I'm going to do read and insert together because we don't have time, right? I'm like, let's see, check if it is inside already, right? If it's inside, I'm like, hey, if you were inside, right, how would I need to find you? Then we say, how do you find it? Well, to find it, you first hash it. In other words, I want to see where, if you're inside, you would be at, right? I want to find your position. What I'm trying to do, I'm like, hey, if you're inside, where would you be? Where would you be, right? I need to find you first, right? So I'm going to find the position where you would be. So I'm going to call it index where you would be. I'm going to hash that value, right? I'm going to hash that value. So if I hash it, I'm going to get some index, right? Then, so let's do that one first. So let's define a function called hash. You can call it anything you want, honestly, but just call it hash. And now you have to define your hash function. I feel like this is a part which tricks people. Now, let's say the hash is also, so that's like one you add, it takes a value. So like, okay, so my hash function should simply can just be like return that number you're putting in modulo. Can just be mod self.k. Like this is a simple hash function. Nobody will arrest you. This is a very basic hash function. The hash function can simply be that if I take the number, give me the mod self.k of it. So that means that, so, and you can see here is like, so it's going to be like 0, so like 0 to self.k minus 1, right? You can define the hash function. Somebody will be like return val plus 1, but that can be tricky because val plus 1 means that it can go below, it can go beyond self.k. But if you use this mod hash function, which is the simplest basic one almost everybody uses, that means that the index you get will always be from 0 to k minus 1. Can we all see what I'm trying to say? Like mod will restrict your range of values to 0 to the number minus 1. Makes sense to everyone? That's what mod does, right? Look, if I say mod 5, the answer can be 0, 1, 2, 3, and 4. That is the only range of values it can be if I do mod 5. This makes sense to everyone. It goes from 0 to 4. This is why we gave moment of silence. Okay, silence is over. Does this make sense?
Yes.
Please, other than 2 people, does it make sense to the rest of you?
Yeah.
Other than 3 people, does it make sense to the rest? Like, that's why we're just doing this, right?
Yeah, it makes sense.
Yeah, so it will bound it from 0 to k minus 1, right? So that's a hash function. So I'm like, okay, I want to insert. Now let me first check if it is inside. So I'm like, if you were in, then your position would be, index would be equal to, let's hash you first, self.hash or value. So then that'll give me the index. And I'm like, oh, so then you are inside. So I'll be like, oh, then you are inside. Where's the guy? Like, oh, maybe you're inside 3, right? I'm like, oh, then you're inside 3. So now I'll come and get that bucket, right? I'll be like, let's get that bucket. So let's call the main guy buckets with S. Like, oh, bucket, Mr. Bucket, give me everything. Self.buckets, the parents guy. And that's index. So that gives you a list, right? That gives you a list. As you can see, it's a list, right? It's a list. Then now you can use your for loop, right? Now you can go through it. It can be like for. Everybody understands the hash function, but let's cut it still. Everybody is going with it too. Okay. Let's put that guy here, right? And now you can use your for loop, be like for every item in this. So now you go through this bucket, right? Go through this bucket. You go through this bucket. Now I can go through this bucket comfortably, like if the item is equal to value, maybe the question says if it's inside, maybe you don't even care. Maybe your question is like if it's inside, return true or something. But let's say you don't even care, right? Like you don't care, right? Well, that's what we said for a hash set. It's just like, are you in or not, right? So like you can even have duplicates, right? You can just be like return bucket. So you can just be like bucket dot append. I mean, you can have duplicates in this implementation though. Can you see it? If I do this, I can have duplicates in my implementation. Do people agree? I have duplicates, but nobody cares. In hash sets, nobody comes to read, right? Like we don't come to read.
Yes.
Does everybody? Does it make sense to everyone? Like in a hash set, it just the operations we perform are like, are you in or not? Can I insert you and can I delete you? That's what we care about, right? Like basically. But it's tricky to the deletion. You do a lot of work. You can remove, do many things. But so if you keep duplicates now, you pay the price later. You can also remove the duplicates, right? By first looping through it and be like, hey, it is already inside, therefore I'll not insert. So at every point in time, you have to have one copy in it. That's what I'm saying makes sense. I'm not saying that you design, like it happens in design, right? Like there's a trade-off here. Here, I can make sure that I'll first go through it and check if, this is what I'm saying, I can first go through the bucket to check if value is already inside. If it's inside, I'll not do this append thing. That means that at every point, there's only going to be one copy of value. Does that make sense to everyone? Or I can be like, I don't care, just append it, right? So that if I just don't check first, I'll have duplicates inside the bucket. Does that make sense to everyone? Does that make sense to everyone? Or even want classical music to cool their brains? Okay. Then Delete the same thing. Blah, blah, blah. I think going so. I think I've basically discussed the whole question. You can solve the rest on your own. I think we should end set here and go to the next thing. We don't have time. Are we good? Are we
Yeah.
good? Are we good? Okay, a minute break. A minute break. Calm your brain. Relax. Enjoy life, and then let's resume. Oh, any questions? Other people enjoying that break. You have questions? Time to ask. Time to ask. No question. Okay. 1 to 2 minutes break. Please enjoy it. The person recording can stop.